Hello YouTubers. This video is a small demo on how control Vacon 100 VFD Viaduct Profibus by Siemens PLC. Please do not forget to like the video and subscribe to the channel. At first let's take a closer look at the Vacon Profibus card. To connect Vacon 100 to the Profibus network you can use either OPTE3, either OPTE5 optional card. The difference between these two cards is that OPTE3 has 5 pins terminal, while OPTE5 has DB9 female connector. In this example I am going to use OPTE3 Profibus card. Here is 5-pin connector to connect to Profibus network. 3 LEDs, PS, BS, and FS, used for status indication. Jumper X13 serves as termination resistor. Jumper X14 is used for grounding and shielding setup. To connect field bus cable to the terminals you need to connect data B wire, or red, to the terminal 3, and data A wire, or green, to the terminal 4. You can find complete pinout of the connector in the user's manual. Meaning of status LEDs are as follows. PS LED is red and it is used to indicate Profibus status. If it is off, it means that Profibus DP communicates normally. If LED lights, then it means that Profibus DP connection is broken due broken or incorrectly connected field E bus cable. Wrong configuration or parameterization data of master. Or master is offline due power loss or faulty interface. Next LED is called BS, it indicates the board status. Color of this LED is yellow. If it is off, then it means that option board is not activated. If it lights constantly, then it means that board is in initialization state waiting for activation command from the VFD. Blinking fast, about 1 Hz, means option board is activated and running. It is ready for external communication. Blinking slow, once in the 5 seconds, means that board is activated, but it is in fault state. The third LED is called FS. It is green and indicates field bus status. If it is off, then it means that field bus module is waiting parameters from the drive. If it is constantly on, then it means that field bus module is activated, parameters are received and module is waiting for messages from the bus. Fast blinking, 1 Hz, means that module is active and receives messages from the bus. Slow blinking, once in the 5 seconds, means that module is in fault state. It did not get any message within watchdog time, bus is broken, cable is loose, or master is offline. Knowing the meaning of the indication LEDs is very important to trace possible problems. The jumpers X13 and X14 are located here. Jumper X13 is used to configure terminating resistors. If your Vacon is the last device on the bus it needs to use terminating resistors. To activate the terminating resistors you need to interconnect middle and left connectors of jumper X13. If you interconnect middle and right connections, then your bus termination is off. Keep in mind that by default termination is off. Jumper X14 is used for various grounding and PE combinations. If ground is connected to the cable shield, then interconnection between middle and left connectors on upper row is necessary. If ground is not connected to the shield then interconnection between middle and right connectors on the upper row must be ensured. If cable shield is connected to the PE through RC then interconnection between middle and left connectors of lower row is necessary. If cable shield is connected to the PE directly, then interconnection between middle and right connectors on the lower row needs to be made. If cable shield is not connected, then interconnector needs to be removed. As I mentioned earlier, there are 2 option boards to connect Vacon 100 VFD to the Profibus network, OPTE3 and OPTE5. Option board OPTE3 can be inserted into either slot D either slot E of the VFD. Option board OPTE5 can be inserted into the slot E only. If you plan to use STO and ATEX option board OPTBJ, then you cannot use OPTE5 as OPTBJ option board can be inserted only in the slot E. After the installation of the option board is finished, the Profibus parameters need to be set. It can be done either by the help of the integrated control panel of the VFD, either via software, called Vacon Live. I am going to use software option. You can connect to the Vacon 100 via Ethernet. By default, acquiring of the IP address of the VFD is set via DHCP. If you want to connect to the VFD directly, then you need to set static IP address. To set static IP address, you need to switch to the main menu and follow this path. Main menu, M1, I/O and hardware, M5, Ethernet, M5.9, common settings, M5.9.1. Set IP address mode, M5.9.1.1, as fixed IP. And set IP address, subnet and default gateway in the M5.9.1.8. After you have set the IP address of the VFD, set the static IP address of your configuration PC. Make sure that both devices are in the same subnet. After setting of IP address is finished, start the Vacon Live. Connect Ethernet cable to the socket of the VFD. Click on Drive, and New Drive. Communication settings pop-up window will open up. In the basic settings, select Media as Ethernet and click on Scan. Select your drive from searching results list and click on Connect to selected. After successful connection, all drive parameters will be populated automatically. Select menu M5, I/O and hardware, find your OPTE card and select it. Then click on parameters and set slave address, operate mode as Profi drive. Send parameters to the drive. Setup of the parameters of the VFD is done. Let's go to the PLC side. Start TIA portal and create a new project. Add CPU. I am going to use CPU 1516F3 PNDP. Set parameters for PN and DP interfaces. Profibus is going to be used to control the VFD, and PN is going to be used for communication with PC and visualization. Compile, and save the project after configuration of the CPU is done. Now it is time to add Vacon 100 Profibus OPTE device. General station description is same for either OPTE3 either for OPTE5. You can find it in the hardware catalog, under the other devices, Profibus DP, drives, Vacon PLC, Vacon Profibus DP slave OPTX. Drag and drop device from the catalog. If you cannot find it in your device catalog, then you need to install it. There is link to video in the description on how to do that. Now in the network view you should see two devices, CPU and Vacon Profibus slave. Select Vacon Profibus slave and switch to the properties of it. As you can see, so far it is not networked yet, and there is no master assigned. Click on the DP interface of the Vacon device and drag it to the DP interface of the CPU. Both devices are in the same subnet. Now you need to set DP address of the Vacon VFD. Mine is 10, but you need to set it according to your setup in the Vacon VFD. Now you need to add the telegram. Click on your Vacon station and select Device View tab. Vacon Profibus OPTE support legacy PPOs. So in case you are moving from older series to newer Vacon 100, then you can select any of the PPOs and you will not be in need to make any changes to your PLC program. In this example I am going to use standard telegram ST1. It has 2 control words and 2 status words, that is enough for main task, run the VFD and control its speed. Select standard telegram ST1, drag and drop it into the slot number 1 of the rack 0 of your Vacon slave. You can set the starting address of input and output according to your needs. Compile and save hardware configuration. Download it to the CPU. After upload of the hardware configuration is finished, let's go online to see if their connection between CPU and VFD. As you can see, connection is successfully established, Vacon VFD is online. There is one more thing that I would like to show you before moving to the programming. Select your Vacon VFD slave and switch to the Device View tab. From General tab in Properties, select Device-Specific Parameters. Here you can set the operate mode of the VFD. If you select Local, then operate mode is taken from setting in the VFD. If you select any of Remote, then operate mode will be set according to the settings in the TIA configuration instead of the VFD setting. Let's say, if you select Remote Echo, then the operate mode will be Echo, even if the operate mode in the VFD is set as Profi Drive. It's time to move to programming part. For control I am going to use function block. Create one and name it Vacon 100. First let's add some variables in the table. Input FWD, that is type of bool, is to start forward rotation. Input BWD, that is type of bool, is for start backward rotation. Input reset, that is type of bool, is used to reset fault. Static variables. ZSW is a structure of status bits of the VFD. Bit 0. This bit indicates whether the drive is ready to switch on the power electronics. Bit 1. This bit indicates whether the drive is ready to begin operation. Bit 2. This bit indicates whether the drive is operating or not. Bit 3. This bit indicates the presence of unacknowledged faults in the drive. Bit 4. This bit indicates whether a coast stop command is active or not. Bit 5. This bit indicates whether a quick stop command is active or not. Bit 6. This bit indicates whether the power electronics may be switched on or not. Bit 7. This bit indicates the presence of warning or alarm information in the drive. Bit 8. This bit indicates whether the drive is operating and the actual speed value matches the setpoint value. Bit 9. This bit indicates whether the field bus master should take control of the drive. Bit 10. This bit indicates whether the setpoint value has been reached or exceeded. Bit 11. This bit is not used. Bit 12. This bit indicates whether the drive is in the run state or not. Bit 13. This bit indicates whether the drive is in the ready state or not. Bits 14 and 15 are not in use. The actual speed value used to indicate the drive operation is a signed 16-bit integer. The sign of the actual value indicates the current direction of rotation. When using standard telegrams 1 or 20 for control, the speed actual value used is normalized according to the following table. The percents are of the maximum speed, that is set in the parameter 3, 3, 1, 2, maximum frequency reference. First let's take a look at the status bits. By the help of the memory slicing I do extract bits from input area. The value of actual speed needs to be normalized. Instruction norm is used here. The value input is normalized by mapping it to a linear scale. Min and max parameters are used to define the limits of a value range that is applied to the scale. The result at the output is calculated and stored as a floating point number depending on the location of the value to be normalized within this value range. As the result is between 0 and 1, it needs to be multiplied by 100. The control word consists of the following bits. Bit 0. Switching on or off. It is used in combination with other bits to enable operation of the drive. Bit 1. Coast stop command. It is used to request a coast stop to be executed. Bit 2. Quick stop command. It is used to request a quick stop to be executed. Bit 3. Enabling of operation. It is used in combination with other bits to enable operation of the drive. Bit 4. Enabling of ramp generator. It is used in combination with other bits to enable operation of drive. Bit 5. Freezing of setpoint. It can be used to freeze the setpoint value by the drive. Bit 6. Enabling of setpoint value. It can be used to disable the field bus setpoint value. Bit 7. Fault acknowledge. The rising edge of this bit is used to acknowledge faults in the drive. Bits 8 and 9 are not in use. Bit 10. Control by PLC. It is used by the Profibus DP master to indicate that it is in control of the slave and that the commands sent by a field bus are valid. During operation this bit must be true. Bits 11, 12, 13, 14, and 15 are not in use. In this example I am going to use predefined commands to start and stop the drive. The setpoint value used for controlling the drive is assigned 16-bit integer. The direction of the rotation is indicated with the sign. Negative value is for reverse rotation, positive value is for forward rotation. When using standard telegrams 1 or 20, the speed setpoint value used is normalized according to the following table. A setpoint value needs to be scaled. Instruction scale is used here. It scales a floating point number by mapping it to a specific value range. The value range is specified with the min and max parameters. The result of the scaling is an integer. In my example, setpoint value needs to be divided by 100. It is time to test the application. For test purpose I have created a project with TP900 comfort panel. Here I have one screen with all the necessary controls for a simple application that enables monitor and control of the VFD. This text block contains information on each and every status bit. Here you can see status of bits visually. Also, by clicking each individual bit, corresponding text will show up. This field is used to monitor actual speed of the VFD. Here you can set the desired set point. These buttons are used to control the direction of the rotation and fault acknowledgement. Let's test everything in action. As you can see, some status bits are already active. The meaning of them can be viewed by clicking each of it. Let's try rotation forward at 40%. The pattern of status bits has changed. VFD reach 40% of maximum speed. Again, meaning of each bit can be viewed by clicking on each of them. Let's try reverse rotation. Please take a closer look at the actual speed value. It is negative. Let's try to change the speed setpoint to different values. VFD reacts to these changes immediately. That is what I wanted to show you today. If the video was useful for you, please do not forget to like it and subscribe to the channel. Thank you for watching and happy coding.